Hello, I'm Cyril, and this is my fourth lab experiment, Unix lab experiment. In this, we have to do base conversion using shell scripting. So we have 5 conversion. The first one is from decimal to binary, the second from binary to decimal, third from octal to hexa, fourth from hexa to octal, fifth from decimal to hexa. Moving on to the codes, the first one, that is from decimal to binary. So what we're gonna do is we're gonna ask the user for a decimal number and store it in DEC. Then we're going to create a B variable, so B string actually. So what we're gonna do is we're gonna into the B string we're gonna keep on adding all the values that we're gonna get by taking the modulus of DEC, and then we're gonna divide the number DEC by 2. So into the B, the remainder that is we're gonna get after taking the modulus going to get stored, and we're gonna print it out using echo, and we're gonna get the value. So the second one is from binary to decimal. In binary to decimal, we're gonna first ask the user to enter a binary number, and we're gonna read it into bin. So what we're gonna do is we are going to take the modulus by 10, and so we're gonna divide it by 10, and then we're going to multiply the value that we're going to get as the remainder by 2 raised to power the number. So like if it's 0 to 2 raised to power 0, the next one is going to get 2 raised to power 1, and then 2 raised to power 2, and so on. And then in the end we're going to add them all, and that is going to give us the decimal value. The third is from octal to hexa. So first we're going to ask for the octal number from the user. So here first we're going to convert the octal to binary. So for that we're going to take the base as 10. So we're going to find the modulus and we're going to divide by 10. So here instead like in the previous one we used 2 raised to power the number, we're going to take 8 raised to power number. So now after we're going to get the binary, we're going to convert it into hexa. So for that we're going to take the modulus of it and we're going to divide it by 16. So now we're going to check if the number is equal to 9 or greater than 9. If it is equal to 9, then the remainder we're going to get, that is going to be the hexa value, and if it is going to be 10, then it is going to be equal to A. If it is 11, it's B, 12 C, 13 D, 14 E, and if it is 15, then it is F. So and then we're going to print out the hexa value. Then we have from decimal to hexa. So we're going to ask the user for the decimal number. Here what we're going to do is we're going to take the modulus and we're going to divide by 16. So if the modulus or the value of the modulus is going to be 9, then it is going to be the same value that we're going to get, and if it is going to be 10, then we're going to replace it with A, and if it's 11 with B. If it's 12, we're going to replace it with C. If it is 13, we're going to replace with D. It's 14 E, and it's 15, then we're going to replace with F. And then we're going to print out the hexa value. So we'll run it. First one is decimal to binary. So let's take the value 15, and we should have 4 ones. So we get the binary as 1111, and then from binary to decimal, that is the second one. So from binary to decimal, let's take 1111. We're gonna get 15 as the decimal value, and then from octal to hexa, that is the third one, we're gonna take 55, and we get the hexa value as 2D. And now for hexa to octal, let's take 2D only. Should get 55, so yes. And then the last one is decimal to hexa. 45 should give 2D. Okay, so yeah, that's it with the program. Thank you.